So I want to jump right in and introduce our next speaker. And for this one, I'd like to bring out Lewis to tell you all about the new things you can do with state channels. Please give Lewis a big round of applause.
Thank you. Hello, everyone. Nice to meet you. It's really a pleasure to be here. Where did I put the slider? Here we go. So yeah, before we get started, so I can adjust the speech to the audience. Who in the audience is using NeoVim? We got 2, okay. Who is developer? So about half. Okay, so let's try to work with that. Yes, I try to balance. State channel can get technical. Let's get right into it. Inject Nitro in your stack. How to accelerate decentralized application, DApp, on top of existing smart contract. And we usually speaking here about layer 3. So everyone knows the layer 1, layer 2 scaling mechanism. 10 years ago has been initiated and supported by Vitalik himself, the state channel scaling mechanism. And this has been a painful road of research, development, and failures. One of them that you probably all know, that is a live network in production, is Lightning Channel on top of Bitcoin. And this is powered using state channels. State channel, though, on Ethereum are much less rare in production or popular projects. So how to build high-performance apps with state channel? Before we get started, I'm going to ask a question to the audience. How many MIPS do you think the Ethereum mainnet is supporting? MIPS being million instructions per second. This is kind of an old way to measure CPU speed, I would say. So does anyone in the audience want to give a wild guess? 1 times 10 minus 5. Well, because these are million, it's a little higher than that. In every transaction, you can pack a little more instruction, but it could be slow, actually. Anyone else? 80? Ten minus exponential minus 5, right? So like, yeah, I can't even describe the number. Like 10 instructions per second. 800 instructions per second. So I'm going to give you another scale, another hint. A recent Intel processor is about 400 billion. Let's go on the next slide. I'm going to unveil. Somebody else wants to give a wild guess? How many MIPS? This is really important, you know. Ethereum is a global computer, and we measure those kinds of computer by MIPS most of the time. Now, teraflops for the floating number for the AI people, but MIPS used to be a very important one. So it's number of instructions a CPU can like process per second. Okay, so let's put it down on a scale. The Intel i9 CPU, 400,000 MIPS. 412 billion instructions per second. Now, for the older people who ever had one of these, Atari, about 1 MIPS. It's already pretty good. Actually, there is a typo, 1 million instructions per second. Don't read 1 billion, it's a typo. Here is Ethereum, a third of a MIPS, 350,000 instructions per second. That's not bad. And that means with consensus of all worldwide connected nodes agreeing on every instruction. We shouldn't be comparing a network with a CPU, not the same thing. But it gives you an idea of like scale, and we can speak about global demand, where the internet, the cloud computing has been doing, and this is a hot topic now with AI. We need more and more data centers, compute power. Okay, a small word about myself. It's traditional in the talk. He already made me an intro, so I will go quickly. Yeah, I don't know if it looks like me. This is my AI version. So I'm the open source maintainer of statechannel.org, which is historically the Ethereum initiative for state channel. I'm the initiator of an ERC called 7824. I invite you guys to have a look. And my work is to build the next generation of financial infrastructure, high-speed trading network, hence why we use state channel. And in the last month, I've been spending more time speaking with AI than with real people. Like today might be the maximum of myself speaking to human. So yeah, to give you some perspective back to like where we are with blockchain, we don't even utilize, our compute power to the maximum currently on blockchain. So the adoption is not here. But the rest of the world, we're talking about close to 12,000 operational data centers, which each one of them have thousands of Intel Xeon processor, which process billions of MIPS per second. And we're talking about 5% of global world power consumption. This is ridiculous. This is growing. This might be doubling in the next years with the AI race. So yeah, I can't even put a scale if we would compare Ethereum and 12,000 data centers, but the data centers are a network of compute, so Ethereum is. But that's not the essence and the idea behind Ethereum. It's very important to understand that it's a shared ledger where everyone agrees on the execution of the instruction. Most Web3 applications must, though, adhere to the real-world environment, this hungry for compute society, mass consumption that we are facing. And this has always been a recurring topic. Ethereum scaling, how do we scale there? And there is this Ethereum roadmap. We're talking about L2. This is accommodating the micro fraction of us DeFi user, which is absolutely not representing the billions of users using the internet. So yeah, maybe now it's fine because we just are the 0.01% of actual blockchain users. Later on, you can imagine it's obvious that Web3 applications are going to need to scale like, Tinder scale, Twitter scale, YouTube scale kind of applications. Hold my beer. We might already have the solution. As I mentioned, State channels are already 10 years old, nothing new. The first mover of Bitcoin already were thinking Bitcoin is never going to cut it. We're going to need to do like Visa type of payment flow processing. So let's come up with Lightning Network. So state channels are not something new. We just were struggling with an adoption system. So there are a way to teleport yourself away from a blockchain off-chain and transact off-chain without any fees and, let's say, latency, finality. So they are the true peer-to-peer TCP/IP connection. It can go as fast as the hardware gets. And this is very important. So the state channel, you can think of it as an elevator from the blockchain to the fast compute world. So this state channel could be the bridge from, our smart contract layer to real-world compute use case. So it offers instant off-chain interaction, natively chain agnostic. This is the oldest chain agnostic technology we know of, much older than cross-chain intent, and this has been around for a while. And back in the days, people at Bitcoin figured out, let's do some hash time lock to swap Ethereum with Bitcoin without central authority, 2013-ish. It's fully horizontally scalable. Any blockchain is not horizontally scalable. Horizontally scalable means you add more server, you will have more throughput in a scalable way. There is no bottleneck in state channel. So most of us actually already use state channel when you log fund and go off-chain. For example, perpetual DEX. You log a deposit in, and then you trade with a off-chain order book. So this is actually quite common. Just people don't call it state channel, though they mimic exactly what a state channel is. Every time you escrow and do business off-chain, which probably many GameFi industry are doing, because they need the performance, the real-time gaming. So they already do it. So what's the problem? So let's go from the theory to practice. At Yellow, we have been 4 years using state channel, and we moved from the theory to the practice. And it was a painful journey that I'm here for sharing it. So in theory, they are simple, but in practice, you need to come up with an off-chain protocol, and they are very hard to design. They are nothing alike that most of us developers know. It's not like clean RPC. You need to come up with new off-chain state machine. I pass you the detail. They are very difficult to design, and you can discuss with your engineers for weeks and weeks without coming to a consensus on the architecture of your protocol. It's painful. It's scalable, but you're gonna need to design your own peer-to-peer network to be scalable. So are you gonna use libp2p? Are you gonna do your own routing, network mapping? How do you build a peer-to-peer network from the ground up? What's the direction? This is not a small architectural endeavor to design a peer-to-peer network. It's cross-chain, but there is no developer consensus on what is a state channel, how we should describe it, and what are the types. This is one of the big pain points of the practice. As long as there is no chain-agnostic cross-chain norm, state channels are hardly cross-chain because everyone uses another language to express it. For the story, in Texas consensus, I was with the Cardano CTO, French guy, great guy, and he say, "Oh, I love state channel. We support it natively on Cardano." I was like, "Oh my god, why somebody would do that?" You know, because they are great, they have a great potential, but it's untapped gold mines today. And obviously, a Cardano state channel would be radically different than an EVM implementation or a Bitcoin hash time lock. So the solution, obviously, is ERC, 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 standardization, and not only ERC, the new stuff called, I guess, CA, the chain agnostic RFC, and we need to write documentation. We need to get you developers involved, commenting. This is a request for comment. And only then, when we have a developer consensus, we can build on this our SDK. An historical project that started maybe almost, 8 years ago, gave birth to a framework called Nitro. And Nitro is great. We love it. We worked years with this guy trying to make it going to production. And this is where we had those pain points, and in practice, we couldn't see the end of it. Hence, the initiative of Nitrolite, which is a simplified version of Nitro, within the same ERC, and we try actually to provide more responsibility to blockchain for setting up channels, so the developer have to do less painful work off-chain. Our entire focus here is developer user experience. So our work on state channel recently, we have simplified the legacy Nitro, made it Nitrolite, which means dynamite. We created a RPC message protocol, a standard based on RPC for request response, which can be understood as state channel states. So people don't need to come up with new messaging protocol every time they want to use state channels. We created a TypeScript Go SDK to allow rapid development of apps. And since we abstracted the backend and the solidity from the developer, from the RPC, there is no need for you guys to eventually, you can start making a Nitro app like a DApp, and you wouldn't have to worry about making a custom solidity adjudicator. This is our contract. In EVM, you just need to implement an interface. And you wouldn't need to write like a custom RPC backend server peer-to-peer network. It comes out of the box. Okay, I got 2 minutes. How does it work? So you can see that, those layers are what made the internet great. We could build with layers and only focus on improving each layers rather than rebuilding the entire internet stack. And, blockchain, we have this layer 1, layer 2. On top of it, you can deploy the Nitrolite smart contract. The contract is simple enough to work in pretty much every runtime, EVM, WASM, you name it. And Nitrolite is a state channel management service that focuses on escrowing digital asset and communicate with Teleport. And Teleport is a mesh network, a peer-to-peer network that makes a virtual ledger on top of every blockchain that has Nitrolite. So we can expand our layer 3 network by simply deploying Nitrolite, and anyone can check in some collateral and Teleport this collateral on the virtual ledger. So once the virtual ledger is operational, somebody that checks in asset from, say, Solana can be using an app that was intentionally developed for base chain. And there wouldn't be any compatibility, recoding, adaptability. This would work out of the box. So I show two use cases. One of the use cases is that you can just do, for example, games, two players playing snakes through their screen, or chess, or tic-tac-toe with money at stake. Or you can think of a 9 players poker table playing with web clients and entirely checking in their chips in the teleport infrastructure, and then they just send RPC message to each other about any play they are doing, and out of the box, this will adjudicate who is the winner of the game. And the last one, you can just have typical client-server architecture, something everyone is familiar with, through this, proxy middleware that will give you, this blockchain virtualization layer. So you don't need to speak to blockchain anymore when you code your apps or your server. You just need to understand the virtual ledger. Alice has 1,000 USDC. Okay, you can trade. Okay, you can play on the table, etc. Well, my time is done, so I'm going super fast. You can install and visit the GitHub ERC7824, npm install the Nitrolite package, and you can get things started with the Nitro RPC. And yeah, that's it. Please feel free to scan. It's going to bring you to the website. You're going to see some user doc, and we'll update it soon with the Nitrolite SDK. Thank you, everyone.